Good morning, class, and the session is being recorded. And again, if there's any issue with privacy, please turn off your audio video. Make sure you don't put anything in the chat and change your name to initials. Good morning, class. We are looking at section 3.1, derivatives and rates of change. In this chapter, we will look at derivatives and rates of change, the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, derivatives of the log functions, and differentials. So we did cover the concept of a limit, okay, as far as convergence and divergence is concerned, the definition of a limit, okay. And so basically, convergence refers to the fact that the function approaches a number, okay, such as L. Divergence means we go to infinity, negative infinity, or it doesn't exist. Definition of a limit, the limit of f of x as x approaches a equals L, meaning when x gets closer and closer to a from both sides, then the functional value, the y coordinate, gets closer and closer to L. It only exists under the condition that the one-sided limit exists. That means the left and right they give us the same thing. So this is read A from the left, this is read A from the right. And in all these cases, we noticed that as x approaches A, the limit exists and it's equal to L. In this case, f of A equals L, which means it's also continuous. In this case, f of A is equal to something else, B. And in this case, f of A is not given to us, it's undefined. Also, the definition of a VA, vertical asymptote, when the limit approaches infinity or negative infinity, when x goes to A or A from the left or right, then the line x equals A is the equation of a vertical asymptote. In the case of a horizontal asymptote, if the limit exists and it's equal to L, when x goes to negative or positive infinity, then we say y equals L is the equation of a horizontal asymptote. All right. Now, let's go with the new section. Okay. And what you're looking at is rise over run. What you're looking at is the definition of a basic slope class. As you recall, the slope was defined as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Change in y over change in x. The way you write that, okay, if you look at this first one, comes from here. If you are looking at this one, class, take a look at this last one. This distance is h. Do you see that? This gives us the second one, everybody. And f of A and f of B. If instead of, let me use a different color. If we call this Q, okay, of a B, then it's f of B. In other words, instead of X, if we call this B, then that gives us the third definition. My point being, all those three are the same, rise over run, everybody. So pay attention to this. By the way, sometimes this distance, this is called delta x. Sometimes it's called h, and so on and so forth. All right. This f of a plus h minus f of a, this is the same as delta 1. So what's happening here? We can easily find the equation of this line. This blue line that you can see is called the secant line. We have 2 points, find the slope, you're done, end of this story. But what if I want the slope at 1 point? That means the slope of a tangent line at P. Take a look at Q. Move it, so Q and P, they give you the secant line. Now move the Q and get closer and closer to P. As the secant line is getting closer and closer to the tangent line, their slope becomes closer and closer. And that's the idea. So distinguish between the secant line and the red one, which is the tangent line. And that is important to understand. So the slope of a tangent line is the limit of the slope of a secant line as Q moves towards P. So there are a couple of different ways of writing it. Take a look. We can say the slope M of tangent line is the limit of M of PQ. Remember, this is PQ, okay? As Q approaches P, what is happening to Q? It's moving towards P. That's one way to write it. Other ways to write that, take a look at this one, take a look at this one, and bring it here and let X approaches A. Take a look at this one. Class, X is approaching A. X is approaching A. We are looking at the first one. What about this one? Look at this last one. Look at this last graph. H is getting smaller and smaller. That means what? This point is getting closer and closer to. I hope you see they do have absolutely the same meaning, which gives rise to the equation of a tangent line. Now, do I have to memorize that? Absolutely not, because we remember the point slope. Everybody remember the point slope. It was, I hope you remember that. The equation was y minus y1 equals m times x minus x sub 1. So what I'm telling you, when we say y minus f of a, class, what is f of a? Y sub 1. When we say f prime of a, it's m. X minus a. What is a? X sub 1. This is a, right? The point being, it's the good old point slope, everybody. Okay. And so we call this f prime of a, this slope of a tangent line. F prime of a is the limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a over h as h approaches 0. There are different definitions for them, but both they refer to the same thing ultimately. So again, a quick recap. We have this rise over run, okay, the average rate of change of y with respect to x. This is the rate of change. So the good old slope is the average rate of change of y with respect to x, rise over run. So we are looking at this blue line and the slope of that. So this is the rise, delta y, this is the run. What happens as the run gets smaller and smaller, delta x or h? Again, we can call this delta x or h, in which case this becomes x sub, and normally we go with x if this is anyways x sub 1 plus h. Okay, what happens when delta x goes to 0 or h goes to 0 or x sub 2 goes to closer and closer to x sub 1 becomes the slope of a tangent line. And those are the same definitions. We are repeating the same thing known as instantaneous rate of change. So what is the average rate of change? Slope of a secant line. What is the instantaneous rate of change? The slope of a tangent line. Now the derivative f prime of a is the instantaneous rate of change of y with respect to x when x equals a. So those are all definitions. So what we want to do is look at a simple example and put all of this together. Starting with part A, it says find the average rate of change, which means basic algebra class. Now, even if it doesn't say average rate of change, meaning using this, as long as they give us 2 points, that's the meaning of it, okay? Because they may just ask for what is the rate of change from x equals 2 to 4. On the other hand, in part B, even if they don't say instantaneous, what is the rate of change of f of x at x equals 4? So 1 point means instantaneous, 2 points means average. Now, the first part is very simple. Just plug in. What do you plug in? 4, we plug in 2 for the numerator, and the bottom is 4 minus 2. So this one is really the slope of a secant, and you have a line, you have 2 points, come up with this row, rise over. All right, so let's plug in 4. That becomes 4 squared minus 3 times 4. Minus, let's plug in 2, that becomes 2 squared minus 3 times 2. Okay. And obviously, this is 4, okay, minus, this is negative 2. That means 4 plus 2 over 2 or 3. So the first part is elementary algebra, everybody. The first part is elementary algebra. We want to do the second part, and we have 2 ways to do it. So I'm going to quickly show you both ways, okay? I want to quickly show you both ways, everybody. So first, let's stick with one of them. Let's go with that. Again, there are 2 different definitions. Both of them you should be comfortable with. This definition is used more often for the general case of f prime of x. Because of that, you want to stick with that. So what are we looking for? F prime of a equals 4. Replace the a with 4. And now do the math. Okay, class? And now do the math. Okay? And so let's plug in 4 plus h. So 4 plus h squared minus 3 times 4 plus h minus. Now, for f of a 4, again, you can plug in, or we've already come up with 4. So instead of the second brackets, you can say, I've worked it out. I know the answer is 4. It's your choice. Either way is fine. Now this, we've done that many times. So I'm going to quickly remind you of a plus b squared is a squared plus 2ab plus b squared. Be very careful with that. And so therefore we have 4 squared, which is 16, plus 2 times 4 times h, which is 8h, plus h squared. This is minus 12 minus 3h. And as I said, you can just replace it with 4, or you can say 16. This is minus 12 and apply the negative sign. I hope you see what happened. So let's actually do that. This guy cancels out this guy if you want to go that route. Minus 12 and plus 12. And then 8h and negative 3h go together. They give us 5h plus h squared. So the numerator is left with 5h plus h squared. This is the numerator, so we can factor out the h. Okay, class, this is the numerator. We factor out the h, we drop the h. Now we replace the h with 0, gives us 5. We are done. Okay, this is a very simple class. I hope everybody is comfortable with that. And this is it. Now, what I want to do, I want to quickly show you the second method. Okay. So let's actually do that. So just for practice, it's really a good idea to do this for practice. Okay, so I am looking at this function. Okay, so I wanted to write the function so you see what we are doing here. And so I want f prime of a is the limit of f of x minus f of a over x minus a as x approaches a, where we said a is equal to 4. So now we are going to change this to f prime of 4 is the limit as x approaches 4. The numerator is f of x minus f of 4, and the denominator is x minus 4, and this is the limit as x approaches 4. Let's see what happens to the numerator. The numerator is f of x, so what I'm going to do, I'm going to use a different color, f of x, x squared minus 3x. And then f of a, I hope you remember we did f of a already, and it's minus 4. Now I'm going to factor the numerator. And I hope you realize if you plug in, you get 0 over 0. That's what's going to happen in calculus all the time. And since x is approaching 4, I gave you the, a hint that we should have a factor of x minus 4. You want two numbers. The product negative 4, the sum is negative 3. So you get x plus 1. So this is the limit of x plus 1 as x approaches 4. If you plug in, you get to the same answer, class. And that's really the key. You have two different ways of doing that, class. With practice, you decide what works best for you. However, the method that we went over before is more general, especially for the sake of the next section. Okay, class? All right, let's go to the next example, everybody. All right, in this case, we want to find the equation of a tangent line, and the function is given and a pair is given. What is important to know, the pair, class, as long as we have the x, that's good enough, because they may not give us the pair. 1, when you plug in, you get 1. For the sake of argument, if they said at x equals 5, then that means the pair is 5. Example. I want to make sure that you know. Let's say at x equals 5. That means 5 comma 5 squared. So that is the pair. So you should be able to come up with the pair. I can't emphasize this enough. Therefore, we are going to calculate now the equation of a tangent line by first finding the slope, because we need two things. We need a pair, it's given, and we also need the slope. So let's go with one of the definitions. For example, the one which is the limit of f of x minus f of a over x minus a as x approaches a, and a is 1. Okay. Now replace the f of x. You get x squared. Okay. This is simple factoring. Everybody knows how to factor a squared minus b squared. Remember, 1 is 1 squared, 1 cubed, anything you want it to be. So a squared minus b squared. So a is x and b is 1. Now x minus 1 cancels out. Now replace the 1 and you have your slope. Now the rest is easy. You use the point slope. Y minus y1, that means y minus 1 equals m, which we found it to be 2, times x minus x sub 1, which is also 1. And we put this in slope-intercept form. Slope-intercept form. Okay, everybody? Okay. We are done. But just for the sake of argument, let's look at the second method for the sake of finding the tangent line quickly. If we go with this method, everybody, again, this is practicing, okay? Now, A is obviously what? 1. So let's put 1 plus h into the function. It's just 1 plus h squared. And then we put 1. We already know the answer, so you don't have to put the 1 in there. You know the answer, just either way. Now you're going to expand that. You've done this many times by now. This is 1 plus 2h plus h squared. Okay, the first one squared, you get 1. 2 times the first times the second is 2h. This is h squared. 1 and negative 1 cancel each other, everybody. The numerator, we can factor out the h. Now the h drops. The limit of 2 plus h as h approaches 0, and that's the same, meaning this one is the same as this one. And of course, the rest is elementary algebra. I just wanted to show you how to arrive at the answer, okay, using the second method. Do you have to do it by both methods? Absolutely not, but you need the practice, okay? You need to practice to get comfortable with that. Okay. We want to find an equation of a tangent line, and that means we need a pair. X equals 16, y equals 4, that is given. So what else do we need? We need this slope. And we are going to come up with this slope. And again, I'm going to emphasize this, that the pair is given. They don't have to give us the pair class. All they have to do, okay, at x equals 16, I hope you see that if you plug in 16, you get 4, okay? All right, so having said that, let's evaluate the differentiation formula for the slope. So we can find the slope of a tangent line as follows, where a is 16. So we are using this formula, replace the a with 16. Now, you replace the a, you replace the x with 16 plus h, and then with 16. Now, for the second part class, for the first part is very obvious. For the second part, you have two choices. You can say square root of 16, or you can say 4 because you already have it. I want to keep it as a square root of 16 on purpose, class, okay? Because what if, for the sake of argument, they just didn't give us the y, and they said at x equals 15, and the square root of 15 is not a perfect square and it doesn't come out. So keep it as such. It's fine. We know it's equal to 4, everybody, but let's keep it. Now, I hope you realize that if you plug in, you get 0 over 0. That's why we've been practicing. If it's 0 over 0, we have to use our algebraic technique. And the technique involved was to multiply by the conjugate, okay? So you change this minus sign to a plus sign, you put it at the top and the bottom. So we multiply by the conjugate. We have seen this many, many times before. So we are going to keep at it. And so with that being the case, what do? Well, remember, for the denominator, we do nothing. We keep it as a product. For the numerator, whether you're looking at a minus b, a plus b. So this comes out as a squared. That means it just comes out 16 plus h minus the second one comes out. So what you're looking at obviously is this, the 16 and negative 16 cancel each other. The numerator leaves you with h and h only. Of course, the h drops and the numerator is replaced with 1. Okay, everybody? Now, if you replace the h with 0, you get square root of 16, which is 4, plus 4, which is 8. So 1 over 8 is the answer. So I hope everybody is clear as to how we arrive at the answer. What happens next is that we need to come up with the equation of a tangent line, everybody. Well, what do? It's very simple. Y minus y1 equals m times x minus x of 1. Just plug in and you're done, everybody. Okay, plug in and you're done. Now, of course, I want to quickly show you that this is 1 over 8x minus 1/8 of 16 is 2. So we are going to add the 4 to both sides, resulting in what you see here. Okay, I hope everybody is comfortable with that. And now what I want to add, of course, is this class. Remember, the pair that you have at the top belongs to what? Belongs to the original function, right? In other words, this pair satisfies the function. Okay, this pair is supposed to satisfy the equation of a tangent line. If you plug in 16, 1/8 of that, 2 plus 2 is 4. It should work out. Okay, so that's another way of checking it.
Sorry to interrupt, but is that a way to check your work? Is just plugging it back?
Assuming this is right, because if you made a mistake here, you wouldn't know. Assuming this is right, this is what you do. You check your work after you come up with the equation of a tangent line. You check your work by putting 16. It must give you 4. Absolutely magic. All right. Here's the next one. We want to look at this example. The height in inches of a sunflower X weeks after being planted can be approximated by the function. How tall is the sunflower 8 weeks after planting? Again, you have all of these questions and so forth, so we just want to go over the solution. I hope you realize what happens here. Well, the first part is a basic algebra. You just plug in 8. That's all you do, class. Plug in 8. So basically 6 times 8 minus 1/4 times 8 squared. And that's really not a big deal. I think everybody can do that. This is 48 and this is 64. So minus 1/4 of that, or minus 16, and it gives you 30. As far as the units, so take a look at the units. Because you're dealing with word problems, if the units are given, you want to give it back. If the units are given, you want to give it back. I can't emphasize this enough, class, okay? All right, so with that being the case, what is the next part? It's asking for the average rate, which means, again, you're looking at elementary algebra, class, elementary algebra. So you want f of 12 minus f of 6 over 12 minus 6. As I've mentioned it before, anytime you have 2 points, it refers to the average rate of change, okay? If you have only 1 point, it refers to instantaneous rate of change, okay? So again, elementary algebra, plug in the two numbers that you have into the original function. So plug in 12, evaluate it, plug in 6, evaluate it, their difference becomes the numerator. I'm assuming nobody has any problem with that, okay? So for example, this is 72 minus, this is 144, okay, and this is minus 36, and then minus, this is 36, this is also 36, 1/4 of it is 9, so minus 9. So what happens is that the numerator ends up being just positive 9, and the denominator is 6. So 9/6 simplifies to 3/2. The units of the numerator, so take a look at this one, class. Change in y, okay, in inches, over change in x, weeks, so 3/2, and the units 3/2 or 1.5 inches per week. So it's extremely important to pay attention to the proper units. However, when we look at the next one, even if they don't say instantaneous, there's only one point in time, and that means instantaneous. And we can use one of those two definitions. For example, what if we use this definition? All right, where A is 10, everybody, okay? So we want f prime of a 10. F prime, so this is f prime of A. We want f prime of a 10. I can't emphasize this enough. So now f prime of 10, replace the A with 10. Okay, so the limit as x approaches 10, x minus 10. This is f of x, everybody. Okay, and now plug in 10. If I plug in 10, I get 6 times 10 minus 1/4, 10 squared. And what what happens is this is 60, this is 100, 1/4 of it is 25. So 60 minus 25 becomes 35. Okay, everybody, this becomes 35. 60 minus 25 becomes 35. Okay. All right, so I want you to see what happens. Now, I notice that there is a denominator of 4, so we are going to multiply the top and the bottom by 4. Why? Because it's a complex fraction. So when you multiply the 6x, you get 24x. When you multiply the second one, minus 1/4 x squared times 4, 1/4 goes away, minus x squared, and then minus 35 times 4 is minus 40. And the denominator you just write. Now, the denominator is done, and notice x is approaching 10. In fact, if you plug in, you get what? You get 0/0. So all you have to do, factor the top. In order to factor the top, we put it in descending order. Okay, so when we put this in descending order, class, okay, we get minus x squared plus 24x minus 140. So remember, when we want to factor, normally we like the leading term to have a positive coefficient. So we're going to take a negative sign out. So notice what I do here. When I take the negative sign out and I put it in red so everybody can see I did that. So this becomes x squared, this becomes minus 24x, and this becomes plus 140. And this is the easy factoring. You do the factoring x minus 10, x minus 14, and now x minus 10 drops. So what are we left with? Minus the limit as x approaches 10 of x minus 14, okay, over 4. And if you plug in 10, you get minus 4 over 4, which is negative 1. There's a negative sign in front, and that gives us 1, and the units, inches per week. Now, what does it mean? And that's extremely important to understand. Explain the meaning of your answer to part C, okay? Remember, this was the average rate of change. This is the instantaneous rate of change. This means from week 6 to week 12, this is the expectation. This says on week 10 or after week 10, okay, the sunflower is growing at the rate of 1 inch per week. Okay. Now, I know this was a little bit involved because of the fact that this had fraction involved. Here's the next one. And again, we are looking at the first part, the distance is given. The first part, which is the average velocity. Everybody remembers the average velocity is the good old elementary algebra, the total amount of distance over the total amount of time, right? So this part really means distance over time, okay? So S sub C sub 2 minus S sub T sub 1 over T sub 2 minus T sub 1. So that means plug in these two numbers. First plug in 4, and then plug in 2. I'm assuming everybody can do the numerator. This is elementary algebra, everybody. So 2 times 4 squared minus 5 times 4 plus 40, that's the first one, and then 2 times 2 squared minus 5 times 2 plus 40. It simplifies to 52 minus 38. Divide by 2 and you get 7 feet per second. I wouldn't worry about the first part. It's elementary algebra. I hope everybody is comfortable with that. Let's look at the second part. Again, even if they don't ask you for instantaneous velocity, it's just 1 point. That means we go with the instantaneous velocity. So we are going to use this. INS short for instantaneous velocity. Replace the A with number 4, everybody. Replace the A with number 4. Okay. Now that we have that, let's plug in 4 plus H. By the way, we need to plug in 4 also, and you have a choice of plugging in, or remember S of 4, we showed it to be 52. You can use that. It's up to you. So 4 plus H, 2 times 4 plus H squared, minus 5 times 4 plus H plus 40, and this is the second part. This part, first of all, class, as I mentioned, from here, you can change that, okay? Now this one, I hope you realize this was a 2 times 4 squared plus 8H plus H squared, and then minus 5 times 4. Well, you can keep that, and the next step, maybe I use actually a different color to write this quickly. So when you apply the 2 and then put the rest of them together, let me just write it here. So this is 32 plus 16H plus 2H squared minus now 5 times 4 is 20 minus 5H. Okay, plus 40. So I hope you realize that 32 and minus 20 and plus 40 and minus 52, they cancel each other. So you end up with 2h squared plus 11h, and you factor out the h. So the numerator is left with 2h squared plus 11h. You factor out the h. The h drops. Replace the h with 0. You get 11 feet per second. 11 feet per second. All right. Let's look at the last question, class. Suppose that the ball is dropped from the upper observation deck of CN Tower, 450 meters above the ground. S is given as 4.9 t squared. What is the velocity of the ball after 5 seconds? How fast is the ball traveling when it hits the ground? So what I want to do, class, I want to actually show you the general methodology as we come across it in the next section. Instead of finding f prime at a, okay, in this case 5, you can find f prime of x, or you can say f prime of a and keep it at a instead of 5. And the reason why, because we're going to need that for the second part. And also, what if the question was, what is the velocity after 5, after 10, after 20, after 30 seconds, okay? Then you don't want to keep on, evaluating it that. So you want to evaluate it in general as a function of x or a. So let's stick with a and do the math. So we're going to stick with a. Here's the function, and here's the a, and we're going to keep it at a. So we are going to replace the t with a plus h. So we are keeping it with a, okay, on purpose. Now, of course, this one is a squared plus 2ah plus h squared. All of them have 4.9 in front. So if we take it out, so this one again, see a squared plus 2ah plus h squared minus a squared, and clearly we drop the 2 and we can now factor out the h. So we are left with this. And the numerator, class, we can factor out the h. And they cancel each other. So we are left with the limit as h approaches 0 of 4.9 times 2a plus h. Let's replace the h with 0, and we get 9.88. So now let's answer part A, everybody, and part B accordingly. So part A says, what is the velocity after 5 seconds? Replace the a with 5. And that gives us 49. And the units, meters per second. Meters per second. Okay, meters per second. I can't emphasize this enough. Okay, what about the second part? How fast is the ball traveling when it hits the ground? We need to know the time. Okay, when does it hit the ground? Well, here's the function. Okay, when it hits the ground, 400, so that means this becomes 450. It has to cover 450 meters, right? So this is equal to 450. You divide by 4.9, t squared equals 450 divided by 4.9, and you take a root. So you have to work it out, class, okay? So over here, just in case, means, so from here, you're going to calculate the t squared, which is 450 divided by 4.9. T is plus minus the square root of that. You keep the plus, and it gives you 9.6. So you have to work it out, everybody. And now that you have the t, plug into this. See, if I didn't do it with A, then I have to go through the process and replace the A with 9.6 and go through the process of differentiation again. Since I kept it at A, now all I have to do replace this A with 9.6, which makes life much easier. And this is it, class.